Hello guys, welcome to Cyberman443 official YouTube channel. In this course, we're gonna go through GitHub and Git for beginners from zero into advanced. First of all, I need to introduce myself. I'm Cyberman443. I have more than 7 years of knowledge and full in details experiment with almost all programming languages, ethical hacking, and cybersecurity. And Cyberman443 is my new identity, and believe me, the good one. Since the dawn of software engineering, managing the source code had been a great challenge for engineers. A large amount of source code management, SCM systems, and version control systems, or VCS, have been developed in the search for the best one. The quest for the best SCM ended in 2005, when Linux Torvalds gave another open source gift to the world. It was a source code management system, SCM, that he created to manage the distributed development of the Linux kernel's huge codebase. He named the SCM as Git. The industry embraced Git with open arms. SaaS providers like GitHub, Bitbucket, and GitLab added more bells and whistles on top, and within a few years, Git became the ubiquitous source control solution. What's a version control system? Essentially, it's a system that allows you to record changes to files over time. Thus, you can view specific versions of those files later on. A version control system, or VCS, tracks the history of changes as people and teams collaborate on projects together. As the project evolves, teams can run tests, fix bugs, and contribute new code with the confidence that any version can be recovered at any time. Developers can review project history to find out which changes were made, who made the changes, when were the changes made, why were changes needed. What's a distributed version control system? Git's an example of distributed version control system, DVCS. Commonly used for open source and commercial software development, DVCS allows full access to every file, branch, and iteration of a project, and allows every user access to full and self-contained history of all changes. Unlike once popular centralized version control systems, DVCSs like Git don't need a constant connection to a central repository. Developers can work anywhere and collaborate asynchronously from any time zone. What's a Git? Git is a version control system that's designed to make it easier to have multiple versions of a codebase, sometimes across multiple developers or teams. It allows you to see changes you make to your code and easily revert them. Git is different from all other SCMs in many aspects. Why Git? According to the latest Stack Overflow developer survey, more than 70% of developers use Git, making it the most used VCS in the world. Git is a free and open source distributed version control system. Git is commonly used for both open source and commercial software development, with significant benefits for individuals, teams, and businesses. Git lets developers see the entire timeline of their changes, decisions, and progression of any project in one place. From the moment they access the history of a project, the developer has all the context they need to understand it and start contributing. Developers work in every time zone. With a DVCS like Git, collaboration can happen anytime while maintaining source code integrity. Using branches, developers can safely propose changes to production code. Businesses using Git can break down communication barriers between teams and keep them focused on doing their best work. Plus, Git makes it possible to align experts across a business to collaborate on major projects. Git terminology. Before we start, there is an oversimplified explanation of a few SCMs related terminologies. Tree. A codebase is usually a collection of files and folders. It can be represented as a tree data structure, having the project folder as the root node and files or blobs as leaves with subfolders as intermediate nodes. For further discussion, we will refer to the codebase as a tree. Working tree, the source code that we work on and make changes on. All the code that we change or add is saved in the working tree. Repo tree, this is the source code that's kept for later reference. The data in the repo tree is uneditable. To make any change, you have to check out, edit, and then commit the file. Commit, an action to put the code in the repo tree. Check out, an action to bring the code from the repo tree to the working tree. What's two-tree architecture? This is how most of the SCM worked. We make changes in a working tree and commit them to the repo. Repo is usually somewhere on a remote server. Right after the code commit, new changes become available for everyone. Git two-tree architecture. Linux introduced many distinctive elements in Git design, making it different from all other systems. The two prominent elements were the local repository and the staging array. Local repository. Git maintains a full repository on our machines, called a local repository. Developers comment to and check out from the local repository. If needed, these commits can be pushed to remote servers. But each machine works as a full repository containing all information, such as branches, commits, logs, tags, etc. Staging array or cache. Linus also created a cache that holds the code that a developer intends to commit to the repo tree. Any change for local development can be done onto a working tree without worrying about mixing it with commit code. Once ready, changes that are needed can be explicitly added to this cache. Only the changes that are added to the cache will be committed to the local repo. Usually, the goal of working with SCM is to store the code on a reliable server machine, not on a developer machine. Therefore, we finally push the local repo code to a remote server. The complete workflow looks like what you see on your screen. What's a repository? A repository or Git project encompasses the entire collection of files and folders associated with the project, along with each file's revision history. The file history appears as snapshots in time called commits, and the commits exist as a linked list relationship and can be organized into multiple lines of development called branches. Because Git is a DVCS, repositories or self-contained units, and anyone who owns a copy of the repository can access the entire codebase and its history. Using the command line or other ease-of-use interfaces, a Git repository also allows for interaction with the history, cloning, creating branches, committing, merging, comparing changes across versions of code, and more. What's a branch? In Git, a branch is a new separate version of the main repository. It represents an independent line of development. It also serves as an abstraction for the edit stage commit process, which means that whatever changes you make in a branch do not affect your master or main. We call it T&C apply. What's a merge? Merge is the process of taking the contents of a source branch and integrating them with a target branch. Let's get into a scenario where you are given a feature to implement. For example, head glasses for your octopus. Here onwards, we'll call him Octi. What will you do? You will create the head glass branch from your master branch using one of the above branching commands. You will create the head glass branch from your master branch. Then once you are done with all your changes and know that the glass will look good on Octi, you go ahead and merge your head glass branch to your master branch, and maybe then delete the head glass branch, and you will have all your changes in the master now. Octi is looking good there, and while you were creating glasses, someone put a hat on Octi. Aren't that nice? Basic Git commands. To use Git, developers use specific commands to copy, create, change, and combine code. These commands can be executed directly from the command line or by using an application like GitHub Desktop or Git Kraken. Here are some common commands for using Git. Git init. It initializes a brand new Git repository and begins tracking an existing directory. It adds a hidden subfolder within the existing directory that houses the internal data structure required for version control. Git clone creates a local copy of a project that already exists remotely. The clone includes all the project's files, history, and branches. Git add stages a change. Git tracks changes to developer's codebase, but it's necessary to stage and take a snapshot of the changes to include them in the project's history. This command performs staging, the first part of that two-step process. Any changes that are staged will become a part of the next snapshot and a part of the project's history. Staging and committing separately gives developers complete control over the history of their project without changing how they code and work. Git commit saves the snapshot to the project history and completes the change tracking process. In short, a commit functions like taking a photo. Anything that's been staged with git add will become a part of the snapshot with git commit. Git status shows the status of changes as untracked, modified, or staged. Git branch shows the branches being worked on locally. Git merge merges lines of development together. This command is typically used to combine changes made on two distinct branches. For example, a developer would merge when they want to combine changes from feature branch into the master branch for development. Git pull updates the local line of development with updates from its remote counterpart. Developers use this command if a teammate has made commits to branch on a remote, and then would like to reflect those changes in their local environment. Git push updates the remote repository with any commits made locally to branch. Now it's time for a fact. Git is not GitHub. So what's GitHub? GitHub is a Git hosting repository that provides developers with tools to ship better code to our command line features, issues, threaded discussions, pull requests, code review, or the use of a collection of free and for purchase apps in the GitHub marketplace. With collaboration layers like the GitHub Flow, a community of 15 million developers, and an ecosystem with hundreds of integrations, GitHub changes the way software is built. GitHub is a website that hosts billions of lines of code, and it's where millions of developers gather every day to collaborate on and report issues with open source software. As a developer, you can't avoid using GitHub or another Git-based tool on a daily basis as part of your work. It's used to either host your code or to collaborate on other people's code. How GitHub works? GitHub builds collaboration directly into the development process. Work is organized into repositories where developers can outline requirements or direction and set expectations for team members. Then, using the GitHub Flow, developers simply create a branch to work on updates, commit changes to save them, open a pull request to propose and discuss changes, and merge pull requests once everyone is on the same page. Why GitHub? Major codebases have migrated over time from other version control systems to Git because of its convenience, and GitHub has been historically well positioned and put in a lot of effort to serve the needs of the open source community. So today, anytime you look up some library, you will 99% of the time find it on GitHub. Apart from open source code, many developers also host private repositories because of the convenience of the platform. Now let's get started on the important Git-specific concepts that the developer needs to know. GitHub issues. GitHub issues are one of the most popular backtrackers in the world. They provide the owners of a repository the ability to organize, tag, and associate issues to milestones. If you open an issue in a project managed by someone else, it will stay open until either you close it, for example, if you figure out the problem you had, or the repo owner closes it. Sometimes you will get a definitive answer, and at other times the issue will be left open and tagged with some information that categorizes it. Then the developer can get back to it to fix the problem or improve the codebase with your feedback. Most developers are not paid to support their code released on GitHub, so you can't expect prompt replies. But some open source repositories are published by companies that provide services around that code, have commercial offering for versions with more features, or utilize a plugin-based architecture. And so they have paid developers working on the open source project. With GitHub, you can follow a developer or a repository by going to the user's profile and clicking follow, or by clicking the watch button on a repo. In both cases, the activity will show up in your dashboard. Following a user or repository is unlike Twitter, where you see what people say. Instead, you see what people do. One big feature of GitHub is the ability to store a repository. This action will include it in your stored repositories list, which allows you to keep track of projects you find interesting and discover similar projects. It's also one of the most important rating mechanisms, as the more stores a repository has, the more popular and important it generally is. This results in it showing up more prominent in search results. Major projects can have tens of thousands of stars. GitHub also has a trending page where it features the repositories that get the most stars in a determined period of time, for example, today or this week or this month. Getting into those trending lists can cause other network effects, like being featured on other sites, just because you have more visibility. The last important network indicator of a project is the number of forks. This is key to how GitHub works, as a fork is the base of a pull request, or PR, which is a change proposal. A person may fork a repository, make some changes, and then create a pull request to ask you to merge those changes. Sometimes the person that forks a repository may never ask you to merge anything. They may fork your repository just because they like your code and decided to add something on top of it which they don't want to merge back into the original repository. A user may also fix a bug they were experiencing which was specific to them. All in all, those are all key indicators of the popularity of a project. Apart from the above indicators, the date of the latest commit and the involvement of the other in the issues tracker are useful indications of whether or not you should rely on a library or software. GitHub pull requests. In the previous section, I introduced what a pull request is. To reiterate, a person may fork your repository, make some changes, and then create a pull request to ask you to merge those changes. A project might have hundreds of PRs or pull requests, and it's generally the case that the more popular a project, the more PRs it has. Once a person submits a pull request, it needs to be reviewed by the core maintainers of the project. Depending on the scope of your pull request, the number of changes, the number of things affected by your changes, or the complexity of the code touched, the maintainer might need more or less time to make sure your changes are compatible with the project. A project might have a clear timeline of changes they want to introduce. The maintainer might like to keep things simply while you're introducing a complex architecture in a pull request. This is to say that a pull request does not always get accepted quickly, and there is no guarantee that the pull request will ever get accepted. In the example that you see on your screen, there is a pull request in the repo that dates back to 1.5 years ago, and this happens in all projects. It's quite normal and maybe due to the reasons I mentioned above. Along with issues, which are the places where developers get feedback from users, the GitHub interface offers other features aimed at providing a few project management features. One of those is projects. It's very new in the ecosystem and very rarely used, but it's a Kanban board that helps organize issues and work that needs to be done. Another popular project management aid is milestones. It's part of the issues page, and you can assign issues to specific milestones, which could be release targets. Speaking of releases, GitHub enhanced the Git tag functionality by introducing releases. A Git tag is a pointer to a specific commit, and if done consistently, it helps you roll back to previous versions of your code without referencing specific comments. A GitHub release builds on top of Git tags and represents a complete release of your code, along with zip files, release notes, and binary assets that might represent a fully working version of your code's end product. While a Git tag can be created programmatically, for example using the command line Git program, creating a GitHub release is a manual process that happens throughout the GitHub UI. You basically tell GitHub to create a new release and tell them which tag you want to apply that release to. GitHub comparing commits. GitHub offers many tools to work with your code. One of the most important things you might want to do is compare one branch to another one, or you might want to compare the latest commit with the version you are currently using to see which changes were made over time. GitHub allows you to do this with the compare view. Just add compare to the end of the repo name. Webhooks allow external services to be pinged when certain events happen in the repository. For example, when code is pushed, a fork is made, or a tag was created or deleted. When an event happens, GitHub sends a post request to the URL with tell it to use. A common usage of this feature is to ping a remote server to fetch the latest code from GitHub when we push an update from our local computer. We push to GitHub, GitHub tells the server we pushed, and the server pulls from GitHub. GitHub services and the new GitHub apps are third-party integrations that improve the developer experience or provide a service to you. For example, you can set up a test runner to run the tests automatically every time you push some new comments using Travis CI. You can set up continuous integration using Circle CI. You might create a code climate integration that analyzes the code and provides a report of technical depth and test coverage. The GitHub Flow. The GitHub Flow is a lightweight, branch-based workflow built around core Git commands used by teams around the globe, including ours. The GitHub Flow has 6 steps, each with distinct benefits when implemented. Create a branch. Topic branches created from the canonical, the deployment branch usually master. Allow teams to contribute to many parallel efforts. Short-lived topic branches, in particular, keep teams focused and results in quick shifts. Add commits. Snapshots of development efforts within a branch create self-revertible points in the project history. Open a pull request. Pull requests publicize a project's ongoing efforts and set the tone for a transparent development process. Teams participate in code reviews by commenting, testing, and reviewing open pull requests. Code review is at the core of an open and participatory culture. Merge. Upon clicking merge, GitHub automatically performs the equivalent of a local git merge operation. GitHub also keeps the entire branch development history and the merged pull request. Deploy. Teams can choose the best release cycles or incorporate continuous integration tools and operate with the assurance that code on the deployment branch has gone through a robust workflow. Now let's go try using Git and GitHub. First of all, confirm that you have Git. Open your terminal and run git command, Git, and enter. If you see a command not recognized error, you probably haven't installed Git yet. After you confirmed that you have Git, now configure the Git. Your commits will have your name and email attached to them. To confirm that this information is correct, run the code that you see on your screen. Git config --global user.name. That user.name should be your name, like Jack Nelson, and git config --global user.ml. That user.ml should be your email, like jack.nelson@gmail.com. Now let's connect Git with GitHub. In order to prevent having to enter your password each time you push up to GitHub, you must configure Git and GitHub to recognize secured shell or SSH keys that you generate. To check and see if you have any recognized SSH keys active on GitHub, go to https://github.com/settings/keys. If you do not see any SSH keys listed, you do not have SSH configured with GitHub. We can assist with this later. If using macOS X, you can also configure your keychain to automatically enter your password via HTTPS. How to create a new repository and publish it to GitHub. First, from your project direction, run git init to initialize a Git repository. Second, go to GitHub and create a new repository with the name of your project. Third, follow the instructions on GitHub to connect your initialized Git repository to the remote server on GitHub. Note, you must have files in your project directory to commit in order to push anything to your remote server. One of the ways to copy a repository to your GitHub account is using fork, which is available on GitHub's website. Forking a repository essentially copies the project to your online GitHub account. However, to work on that project on your local computer, you must clone the project. As a student, you can get access to the GitHub Student Developer Pack, which includes benefits from GitHub as well as other partners. From GitHub, students receive a free micro account with 5 private repositories. To learn more about the Student Developer Pack, go to https://education.github.com/pack. Now, to learn more about using Git and GitHub, check out the resources that you have in your screen. Git-acm.com, the main website and documentation for Git, and help.github.com, GitHub's help documentation. But it's not the end. Now we go try practicing what we learned to get more expert on Git and GitHub. Now let's go through all we learned to creating a project and pushing it to GitHub. Like here, I want to go to my browser. Here, I open GitHub. I'm inside GitHub because I logged in, but you can just sign in, add your username and password. If you don't have, just create an account, like let me sign up for now. Here you can see, just click sign up if you don't have any account. Here, add your email, and email will be sent to your email, so you can click on it and you can create your account. So I have an account already, so I go to sign in. Here my email and password, I signed in, now I'm inside my GitHub profile. Here we have different menus, my profile, my repositories, code spaces, projects, stars, gifts, and much more, okay? And here, pull requests, ashes, marketplace, explore, and much more. We can search about a project, we can find our own repository, we can go to different repositories, so we can clone different repositories, we can work together in a project, and much more you can on GitHub. You can use like Visual Studio Code's terminal, or PowerShell, or just CMD, or even Git Bash to create and manage your project with Git commands, For now, I use just PowerShell, but you can use just like Visual Studio Code, and here just click on terminal. You'll have a terminal that will work perfectly same as PowerShell or just CMD. Here you can see I can use just terminal. If you don't know about Visual Studio Code, I have a video. I'll put the link in the description, and you can go try and learn Visual Studio Code full in details. For now, I don't want to go try it. I just go try PowerShell. You know PowerShell. Oh, I can just go by CMD. Maybe you guys are better with CMD. So let's close this part. CMD. The first step, we have to write git command. Here you can see now, all computer know this command. It means git is installed perfectly. If your git is not installed, just go to Chrome. Here, write git download. Go to gitscm.com, and here you can download it for Windows, Mac OS, Linux, and here you can see anyone you want. You can click on it. Here for Windows, here you can see 32 bytes, 64 bytes, different versions. Just download it. It's all. Or if you want to learn Git more in detail, just go to our documentations and you can learn it perfectly. Here you can see Git Basics, what's Git Basic, all we learned in our session, and you can go to our other sections too. Here you can go to our Git community too and have fun. For now, I want to close it. If you want to download Visual Studio Code, just open Chrome, Visual Studio, enter. Here you can see Visual Studio Code, code.visual studio. This one is not Visual Studio Code. This one is Visual Studio that we use it for C# and other things you know about that. If you don't, just go search and learn if you want. Here, just click on download and it will be downloaded. For now, I don't use. First of all, I want to go to my documents folder. Here, I want to create my git test folder, okay? I just can create it by graphical user interface. Just folder like git test folder. All my test files will be inside, okay? Or I can just create it here. mkdir, like, any name we can give. Now let's go to documents and ls. Oh, sorry, ls is not for CMD. It's for PowerShell and Visual Studio Code. Okay. Here you can see we have git test folder. Let's go to it. cd git test and dir again. Here you can see inside it we have nothing because we created it new. Now we go to our browser. We go to github.com. And here we create a repository. Just click here, new repository. Here I use my test git project, and anything is okay for now. Create a repository, and we can give a description, like some description, and create a repository. Here I can create a new file. I can upload an existing file. Like you have some files in your local computer. You worked on a project and you want to upload it. You can just upload an existing file, or you can include a README license or without getting it. But for uploading an existing file, you can upload just files, not folders. This is why you need Git command line to upload your folders to, you know. Now here, we'll create a new repository on the command line. We can create a new repository, or we can push an existing repository from command line to GitHub. For now, I just want to copy this link, https://github.com, and I want to come here, git clone. Control-V, enter that project. Oh, sorry, we misspelled. Not git. Here is cloning. Our project is cloned. Now, if I check the IR, here you can see we have test git project is cloned. We learned about cloning. You know, we can clone an online project to a local computer, and we can work on it. Then we can push it again. And GitHub just get rid of all management, project management. You know. Now, inside it, like here, you can see we don't have any file or folder. You know, or I can create a new file for now, like test.html, for example, and here like HTML. And we can add create commit or first commit, you know, what we can add like first commit, we can add a title here, we can add a description here, like my description, and commit new file. This new file is added. Now you can see we got out of that setup page. Now we have to clone again because we add a new file and we don't have it in our local file, you know. And I go to CMD here, git clone, Control-V again, enter. Oh, I'm inside my call, sorry. cd documents, cd git taste, and again git clone. Now it's cloned. Now I go to it, like, let's check dir. Here I have test git project, cd test git project, and I'm inside. Now if we go inside it and check here, you can see we have a git folder that all git files are inside it. It's a GitHub local cloned repository. So what we have to do next, now we can change different parts, we can add different files, like for example, I add a new file, echo like new file, and inside like new file.txt, okay, enter. Now dir again, here we have a new file. Now we check our GitHub status by git status, enter. Here you can see untracked files. Now like the online one, or remote Git doesn't know about this file because we created this file locally, you know. Like here, if I refresh, you can see we know nothing about it because we just cloned it. But any change that happens is locally, you know. Or I can go to test.html. For example, I go find my file, okay. Test.html. I can edit it by a text file. I can use Visual CD Code. Visual CD Code was much easier, but no problem because you have to get used to CMD, PowerShell, or other things, because a lot of videos are about Visual CD Code, but maybe you're not a web developer, you know, you're a software engineer, or you're a mobile developer, maybe you're not using Visual CD Code, you know. Like, these changes happened. Now if I go back, git status, here you can see a new change happened here too, a new modification happened to test.html, and our online remote master doesn't know about these changes. So, now what we have to do. First of all, we get add all these different changes. Now if I go back, git status, here you can see now changes to be committed. All of these changes are ready to be committed. We don't have any red colors in it. Now we use git commit. We had all these things. If like memorizing those comments are hard for you, just come here. Or you just don't get out of that setup page. You know, we'll create a new repository like case2 and description, for example. I don't care. We don't need it. You know, all we need is just setup page. Here you can see you can add git add. All, like as I use git add, all different changes that happen here will be added, will be ready to get committed, you know. Or I can just add git add a specific file, you know, like infile.txt or test.html or any new file that we did add new modifications to, you know. Or just I use git add all. Next thing we use is here git commit. I can use just copy paste it, okay? Being lazy is good as a programmer, okay? I use git commit hyphening. Here we can add a title as we use here, like if we create a new file. Here you can see we named that file as we like created a new file. Here you can see we named it. Where are you? Here we created a new file, for example, like that, okay? Just we're doing it online. Here you can see we give a name for our commitment, that like these changes that will be committed to GitHub, to remote server, what will be our commit, like commit title and commit description. Like here we add it by code, git commit hyphen name, and like my first commit, And another hyphen name, this one will be our description, as we have here, you can see. What's our description? Like description, I don't care, you know. Just enter, and all these comments is my first comment, 2 false changes, 6 insertion, create mode, and all these comments are added. That is still they are in our local system, not online. So what we have to do next, let's come here. So let's go back. I don't want to create a new file because I want to be in this page, you know, I want to see it. Now, because we cloned an online project and we worked on it, we don't need to add like git branch-main or git remote add origin, it doesn't matter. Just we need to push it, git push-new origin master. Control V, enter. Here you can see branch makes it a track, and in rating, counting objects, anything is pushed successfully. If I go back, here refresh, here you can see I have all those different local files that I added. Also, if I click on this additional, here you can see we didn't have this head. We just added HTML and /HTML, you know. That all these changes are coming from local file. Now, the next way that we can go try is here as this. You can create a new repository on the command line. Here you can see I can add a file. We can get, like, let me close this part, okay? I got another CD. I just opened this one on Visual Studio Code, okay? So we get used to different ways that we can use Gitium. Here, I want to go to Documents and CD git taste. I want to create another folder like make dir taste2, for example. Here we annotate and ls. You knew that in CMD we needed dir, but here, because it works as terminal, Linux terminal, maybe you know about Linux terminals commands. For listing files in Linux terminal, we just add ls. It works in PowerShell same too, but in CMD, because it's a Windows command line tool, we use dir. Their commands are different. And here, oh sorry, we entered to our last project, not to case 2. Now it's okay. ls. Here you can see we have nothing. Like here, I want to open folder, documents, like git taste2, yeah, select folder. This folder is selected inside our Visual Studio Code. Now I'm inside my folder. I can create a new file, like here, index.html, for example. Inside it, I can add some codes, and it's okay. Also, I can create some folders like CSS. Inside it, styles the CSS, and here like body, background color, for example blue, and match more. For example, you have a complete project, okay? You create your project, you add your files, and a lot of things, and now you want to push it. Like here, what we have to do, here you can see, create a new repository and the command line. We just add git init inside command line, just we open a new terminal here. Here we are inside this folder. I use git init. A new GitHub connection will be initialized. As you see, the colors are changed. And now next we add our files. Like for example, we just added one file. We can use like git add, as we said, in a specific file by their names. Like I want to just add index.html. For example, before that, okay, let's check git status. You can see there are different changes that has to be commented. Okay. Now if I use git add index.html. Now, if I go by git status, here you can see now we have this one file because we did add one of them. That's same as that. We can add, like, for example, we have different files, different changes, and we can't specify them by their name, you know. We just add git add .xl. All our files will be ready to get committed. Here you can see. Change to be committed. Now, next thing we have to do is git commit -n first commit. Oh, first of all, I forgot something to tell you about. Let me just open another GitHub, okay? For me, when I initialize a Git, here you can see git init. Yeah, here. It didn't request me to add my email password, you know, because I'm using Visual Studio Git management. So because of that, I have an SSH key that for you, like, I want to close this part. Oh, let me here. Yeah. For you, when you add git init, enter, you have to add your email and password, okay? So to not add your email and password every time you want to push something, you want to initialize a new GitHub connection, just you have to come here, settings, and here SSH and GPG keys. Here new SSH key, you can create a new SSH key. For that, like you have to create a local SSH key and you have to add it here, okay? For that, just write like GitHub SSH key Windows, for example. Let me lazy, okay? Because generating a new SSH. Here, just go try it about the SSH, how to generate it on Windows, Linux, and Mac, anything. Okay, so go try it. Or you can use, as I do, you can use Visual Studio Code, Git management, or you can use some other like GitHub desktop and management. Okay, for now, you can just add Git in it, and when a new connection is initialized, you just add your username and password, and it's done. What's the next step? Now let's go here. Here you can see we add our commit. Okay, Git commit -m, commit title like my first commit and another -m, or you can just not add it. Okay, like if you don't want to add the description for it. Okay, just hit enter, and all commits are added. But they are in local, you know, we told you about. We learned it in our slides. Now next thing we have to do is git branch -main. Here it will connect to your local branch, like your local repositories. Control V. Next we add git remote, add origin master. Here you can see just I copy it, and this URL is the same URL as this project that we created, you know. So Control V, just hit enter, and a remote connection will be added to that, and now we can push our files. Now we just copy this one, same as what we did in the last seconds, you know, in the other way. Just Control V, and our local files will be pushed. Now enter. Here you can see all of them are online now. Now if I go, just refresh here, you'll find all your files. Here you can see my CSS folder, my index.html, inside CSS I have styles.css, I think. Yeah, here you can see, and it's done. The other way that we use is pushing an existing repository from the command line. Okay, in this way we have a project that we are working with it every time, like the last projects that we created by the other ways, you know, by cloning and by creating a new repository. We can push these projects just by adding git remote add origin and the link of their online Git repository, and after that we just add git branch -main, and we can push it. It's done. Also, we can import codes from another repository, like import code. Here, just add your repository's clone URL, like you have an online project. For example, your first version of an application or website or something, and you want to create the second version. So you just clone that project, and you can clone it, you can copy it at all, and you work on your like second version or third version and match volume. If you're using Visual Studio Code, you can just come here, source control, and this part is about GitHub. You can open a folder, like a folder that's a local repository and you want to like push it online, or you can clone a repository. Here you can see clone from GitHub, and here you have to sign in by, like here you can see the extension GitHub wants to sign in using GitHub. Just allow, and do you want to code open the external website? Yeah, open, and you can go to GitHub and you can log in. Here, open Visual Studio Code because I'm logged in. GitHub authenticate, wants to open a URL, open. Here you can see my different repositories that I can clone from, okay? Just I signed in, and I can clone a repository or push a repository, a lot of things, just graphically. Like I can click on this one. Here I select my local folders repository because I don't have it for now. You can work on it and you can push it and match volume. Or here, just come, sign out again, and it's all. Also, if you don't want to add your username and password every time, just come here, SSH keygen. Here you can see open git bash, like here I use git bash. Just here, copy this code, paste, and here add your email, for example, like myemail.gmail.com, for example, and hit enter. And here an SSH key will be generated. Enter the file in which to save. You can add your path, like for example, by default it will be added to this part. I want it to be in my like C, users, Kali, and documents. Enter passphrase. You can add a passphrase, or you can just not add any passphrase for now, like 1, 2, 3. Enter same passphrase again, and saving key. Now if I go to my documents, I think the path that we added was wrong. Like, yeah, let's go try it again. Like by default it's okay. I don't want to add a passphrase, and yeah, it's created the keys random images like this. And here if I go to C users Kali, C users Kali, and here .ssh, and this is my public key and this is my private key. If you don't know about public and private keys in encryptions, just go search, and those things are about cybersecurity and management. Okay, according to public-private keys encryptions, you have to have a public key and you have to have a private key. You have to share your public key, but you can't share your private key, because if you were like a hacker, if he has your private key, he can enter to your GitHub. He can change a lot of different things, the same things that you can do by SSH. So we have public and private keys. We go to GitHub again. Let's go github.com again. we went through these steps, in the last minutes. Here are settings, SSH and UPG key, new SSH key, and here you can give the title like paste, and here your key, like here I just open it with a txt file like notepad. Here Control-O, Control-C. Now let's go, just get rid of spaces, and here add this. But this email is not mine and this wrong, so I don't need it. Okay. This email has to be the email in your GitHub, so just add it, and you will not need it to add your username and password every time you initialize connection by GitHub. After that, generating public private algorithm key here. Here we did all these things. Here Control-C, just copy paste these codes, okay? Control-V, paste, enter. This is my agent PID. Now if I go copy this path, Control-C, let's open this port, and here you can see we have to SSH add and our private SSH key, SSH add, and here like paste C users Kali SSH, and inside it we have this file. Just copy this file name, Control-O, Control-C, and Control-V, again, paste, and just hit enter, and it will be done. You will be able to use GitHub without adding your username and password every time initializing a new connection to GitHub. But because, my private and public keys are wrong, because I didn't add my own email, it's just a false email, so because of that, I don't need to hit enter. It's all. So by that, you will be able to work on PowerShell, Visual Studio Code, Git, or anything without adding your username and password. Thank you so much guys for watching until now. To support us and this kind of videos, just subscribe our channel, hit the bell button, like this video, and share it to your friends.